RISACalc is a web-based application for individual component design which provides engineers with an easy-to-use interface that allows for full control over inputs such as geometry and loading, in addition to graphical and numerical results, including robust detail report. In this video, we'll take a look at the wood beam design functionality in RISACalc. So first we need to start a new project, and I'm just going to go ahead and rename this project. Next, then, navigate over here to the Components panel and click Add a New Beam. Before adding our properties or our design information or loading, I'm going to go ahead and click in the Settings option here and open up the code information to assign my wood code. We can see here the different NDS codes as well as the CSA Canadian codes. I'm going to go ahead and look at properties, and we can set the wood properties of this particular member. So we'll choose either solid sawn or engineered wood. In this case, I'll choose solid sawn. I can go ahead and set my species and my grade. Let's make this a number 1 lumber. I can go ahead and set the shape type. So I'm going to make this a 2x12, and then I can set the number of plies. I can also see the properties that are being calculated for the material and the geometric properties as well by clicking the information or I. Next, I'm going to go ahead to the span tab. I'm going to add a backspan here. So let's add it 3 feet, and I'm going to make it a cantilever. So no support condition at the end here. Next, I can go ahead and set my design conditions. We have the options to set the unbraced length for different criteria: out of plane, in plane, top face, and bottom face. I could also change these other factors in the deflection criteria here. I can go ahead to start adding loads, and so I'm going to go ahead and first add a point load. So let's say 250 pound point load in the dead load condition at 5 feet. And then I can also add a distributed load. So let's say 100 pounds, a linear foot, and let's make that live load along the entire length of the member here. So while that's being done, we can see that the load combinations are automatically being created for us. We could go ahead and edit the load combinations and how they're created, but in this case, we'll leave them the same, and now I'll choose to solve this member. This is just going to run the calculation and give me my result. Now, when I go ahead and look at my results, I can see my unity check now. I'm a bit overstressed here, so if I wanted to make a change, maybe I wanted to reduce my load, I can go ahead and click on the load here, and let's make this 150 pounds versus 250 pounds. And I can choose resolve the member, and hopefully now we get a pass. Let's go and turn on some of my diagrams so I can show a shear diagram, a moment diagram, our deflections, and our react. Now if I go ahead and bring up the detailed report, we can start to look at some of the same information, so like the diagrams, or we can more importantly go ahead and look at the calculations. So I can see the controlling limit state, and I can expand that, and I can see all the code references and all the information filled in all the equations. Let's move on. I'm going to go ahead and add in a wood column now. So I'm just going to click the plus to add a column, and let's make this a wood member again. And we'll say it's a solid sawn, and let's make it a 6x6. So we'll choose a 6x6 post, and we'll leave all the material the same. I'm going to go to my span condition, and I'm going to make this a fixed condition at the bottom, and at the top we'll make this a cantilever. So just a cantilever in a little post here. I can look to add my design conditions. I'm going to keep all of these the same, and then just add a few loads here. So let's add a point load at the top here in the downward direction. So let's call this a dead load, and let's say the magnitude is going to be 1 kip. And then a distributed load, maybe we add a wind load in this case, so I'll choose my wind load category and add 150 pounds per linear foot, and we can add up to 250 pounds per linear foot, so we can add this trapezoidal load. Again, the load combinations are being created in this case, and I can go ahead and choose Solve. So when my unity check goes through, in this case again, we're getting a failure. Here we can go ahead and reduce our loads, or maybe we needed to change the size of our member. Maybe I need to go up to a much larger member in this case. So let's go up to a 10 by 10, for instance, and go ahead and rerun the Solve button. Check on this particular member, and we now get a passing result. Now again, I can go ahead and look at all of my diagrams. So we can see here I've got different reactions and deflections, our moment diagram, our shear diagram that we can turn on, and let's go ahead and turn off the load so we can see those a little bit better. We can also see the deflection here, so we can see how the freestanding element is deflecting. Now if I go ahead and look at the detail reports again, I can go ahead and expand different sections of this, so the properties, the diagrams, and the load combinations created, as well as the calculations. So we can go ahead and look at the bending and axial compression. Now if we want to, we could also download this report to a PDF, open it in a PDF viewer. So if I go ahead and click the download button here, the PDF will just really quickly generate and then automatically download here in your downloads bar of your web browser. Then I can go ahead, click it, open it up, and we're just viewing our results. And so you could use this detailed report in your calculations package for your overall project. For more information about RISACalc, including available components and pricing, please visit RISA.com.